think we should probably be kind of talking about our next session now, right, Melody?
Yeah, I think it's time.
I'm super excited for this one because we've heard so much great stuff about serverless and functions. And now we're going to have Davide Mauri come and give us the serverless full stack kickstart. And I'm really excited to hear more about this. Davide.
Hello. Hi, everyone. Yeah, thanks a lot for having me.
Very nice to see you here.
Yep.
We'll let you take the stage and look forward to your talk.
Yeah, sure. Let's go. Okay, cool. Let me share my screen and let's get started with the Kickstart. So I love the keynote because it promised like a very easy, startup time. So that's exactly what I want to show you: how to create a full stack application using Azure Function and also static web apps. So let's get started. Hide this, and so that's exactly the goal of the session. Create a web client. Well, I will not be writing HTML. I will be using already one available with HTML and Vue. That will be our front end, and then for the back end, we will be using Azure Static Web Apps plus Azure Function, since they are so good together. We will be using .NET Core as a language, but we could have used Node or Python or any other language that we like. And we are going to use Azure SQL, specifically the serverless version, to be completely serverless. And that's what we are going to do. Basically take the To-Do MVC app frontend that I like so much because it shows how you can create a frontend with a lot of different web client or web framework as you wish. I will choose Vue because that's what I'm passionate about. And then that frontend will actually work already by itself, but then we want to save the data somewhere else other than the local storage that where the data is saved in the sample. So for example, we need to have a database and a backend providing some REST API behind the scene that will nicely receive the JSON sent from the front end to the back end so that we can do whatever we need, like store the data somewhere. And that's exactly what we are going to do, right? So use this simple and super nice application. Simple, so also great for who is starting to learn coding or to be in this field, but very complete because it will give you a full end-to-end experience. And this is exactly the architecture of what we are going to do. So the client UI will actually send some JSON to the backend. And as a developer, I would love to be able to send JSON also to my database. And this is exactly what we'll be doing, even with Azure SQL, even if it's a relational database. It has been extended and it has evolved over the last year to be able to manage JSON, documents, graph models, geospatial data, all the data you can imagine you can have. So we'll be able to send JSON to Azure SQL. There we'll decide how to actually store the data. I have decided to store data as a regular table, but I could have also stored it as JSON. Do some manipulation, send back JSON to the backend API. So it will be super easy to deserialize what we got into an object and then send it back to the client UI to visualize the result on the front end. That's exactly what we are going to do. Now, to start is super easy. You have to download or install the Azure Function Core Tools. And here's the link and the instruction to do that. You have to download and install the static web app CLI because that will make our life super easy. And I love so much this CLI that has been created by the static web app teams because make local development just a dream. I will show you in a second. And then I can't just type all the HTML right now because otherwise we'll be out of time very soon. Even because I'm not an HTML guy, I'm not super good at creating a front end. I'm I'm better with the back end. So I will be just downloading the Vue client and start from this one to evolve it so that it can connect to the back end, can send data to database, and do exactly what we just did. So starting from these three simple things. Let's just summarize what are the next steps that we are going to do in the next 20 minutes. So create an Azure function to implement the To-Do MVC API specs. Of course, the front end will be sending some JSON, but how should we manage that JSON? Should we support a GET, a POST? How shaped is the JSON that we are going to receive, and how the JSON should be shaped to be correctly manipulated by the front end. So in this To-Do backend website, there are the specification that you just have to follow in order to make a backend compatible with the front end. and then we will update the view client so that we can use the REST API created. And then we will deploy the Azure Static Web App to the Azure Static Web App Engine, and then we will change the API so that we will be storing the data into the database. And then we will do everything with the CI/CD pipeline, because actually deploying the full working solution that I have on my machine to the Azure Static Web Apps can be done, and actually it's really easy to do it using GitHub Action, and that will be a dream. You just push. At some point, you will just push your changes, and it will be automatically compiled, built, and sent to the Azure Web App for production. And then we also want to add authentication support. Then finally, we can have some good chocolate and enjoy what we have done. So let's do it, but not before having explained why I decided to use Azure SQL Database and not something else. Well, as I said, I'm really starting from scratch here. I don't know where this application will be in 5 years, so I want to be able to be super flexible. So I need to be flexible, but I only need to be secure and performant and make sure that our data is consistent. So I want to be flexible in the sense that I want to be able to support any kind of model I may want to use in future, so JSON, so the documents, graph, and geospatial. Maybe I need to have super high concurrency, so Azure SQL provides in-memory lock-free table, which are tables that does not take any lock to implement the consistency of transactions, so you can really have thousands and hundreds of thousands, even million transactions per second on those tables. We even may want to have a ledger table to make sure that all the audit trail of our data is proven and consistent. We may want to use the column store to quickly aggregate data and provide reports, for example, or dashboards. We want to encrypt our data, maybe. We want to apply row-level security. So all these features are within a single database, and you can pick and choose them and use them together as you wish. So it makes super easy for me as developer to improve my application over time, taking advantage of any of these features. And specifically, I will use the serverless version of the Azure SQL because it provides all the features I just mentioned, but in addition, it will also help me to automatically scale up and down when it detects that there are more workload. It can automatically pause itself when I'm not using it. So when I stop working on it, especially for development purposes, I will not pay a cent for it, and it's billed per second. So exactly in a serverless fashion, I only pay when I use it, and for the second I use it, which is great. So let's do that, and if you want to follow me, everything I'm showing here is already on the repository you can see on the screen. There are 3 branches. The first one is the very basic one, the one I will show you right now, and then the version 2 is with the added ability to send data to the database, and the third one is also with authentication, so you can only see the to-do item that you have created, really completing the end-to-end story of a professional, fully working and solution. So here we go. Let's switch to code and build something right now. So first of all, I wanted to show you how easy it is to create the static web app. So I just want to create a directory here. So let's call it Kickstart, and then within the Kickstart, let's create 2 folders. Let's create the client folder where we will store the front end, and then make also the API folder so that it can store the backend code. Let's see what we have. Perfect. Now what I want to do is quickly download in the client API, in the client folder, the HTML that is provided by Vue, the Vue team that already implements basically the to-do list, just using Vue and local storage. But this is exactly what I want to start from, right? So this is what impressed me about the static web app and Azure Function. It's done. So I downloaded something that I want to use as a starting point. All I have to do right now is SWA start. I don't have the API yet. So let's just start the client. Fully working and super rich emulator started. I can just go here and here you go. I have my application working. And of course, hello again here. So this is my application. It's working very nicely. The only limitation right now, it's everything is stored in the local storage. So local storage means, and let me switch to the V1, which is basically exactly this application. But the local storage means that, let's go here. Local storage view page source. So local storage means that this code here, which will probably you recognize if you are familiar already with Vue, is basically saving the item I created into the storage, in the local storage of the browser, right? But then, as you can see, I have a function for when, for example, here we go. I add a new to-do, I remove a to-do, or I edit one. So what I really have to do is now change this code. So instead of calling the function that use the local storage, it will actually create call a REST endpoint. And how can I create a REST endpoint? Well, that's super easy. Again, now let's do something kind of super easy right now. So let's go to the API. What I have to do is just initialize the function environment here. And then I want to create a function written in .NET. Here we go. So here everything is done. Now I want to create a function called to-do, or and using the HTTP trigger, which means this function, when deployed, will answer it to some HTTP call, where I will write the code to actually handle the to-do that I receive, save it into the database in the future, and so on and so forth. That's it. So again, I can go to my folder, now use SWA and add API. And this means that the local environment will actually start the front end, even start the back end, and serve them and make sure that they work well together, taking care of otherwise complex configuration like a course and all this stuff that you usually have to take care of yourself. Now, of course, this is nothing different than before, because my front end doesn't know that the backend exists yet, but we can check if the backend is actually working correctly. And the backend is answering at this address, localhost API to do. So if I send a GET, I should expect to receive something, and that worked. So the function is actually working. Now the function has been created using some boilerplate code. So it doesn't really do much. For example, if we go to the API, and for example do cat to do, which has been created for me when I did function new, you can see it's just an example on how to handle get and post request and then return something. But this is exactly what I need to get started. Now I can remove all this code, put the code in order that will send or store the to do somewhere, and then I'm done. Now, this is just the basic step that you need to get started and to have some working code. Now we have to change the code to make sure that it does what we want, not what the boilerplate code already does for us. So having said that, let's go to the V1 branch of the repository. And here you will see exactly what I did. So the index.html. The only difference between what you saw before and now is that now my index.html has been changed so that it can send data to a backend API instead of using the local storage. And specifically, I'm using the fetch method so that I can send the JSON that nicely the Vue.js framework will give to me and send it to this API. The API are nothing more than just the localhost / API to do in this case. And so my API will be done in this way. Here, for now, I still don't want to connect to database. I just want to create some backend code that is able to handle the JSON that is sent from the front end. I'm just using a list to simulate an in-memory database. So I create a few to-do items, put it in the list, and then I wrote the code to implement the get handler for the get method, the post handler for the post method, and so on. And for example, the get is super simple. If you go at to-do / an ID, I will try to, first of all, I will check if you are specifying some ID. If not, I will send back all the to-do. If you have specified an ID, I will look if there is any item with the ID you specified. If yes, I will return the item. Otherwise, I will return a not found. Super easy. Now that we know how the SWA CLI work, we can just do, so here I'm already in the repository, I already cloned it, it's already on the V1, so all I have to do is, as I did before, start my my emulator here, and then this will start the updated HTML that is able to send via the fetch method a request to the backend, and the backend is now able to get the JSON that has been actually sent from the front end. So everything here should work nicely. Perfect. I have hello world and world hello that are exactly the sample item I created. And here I can, for example, create a new one, new to do. This will be stored in memory. I can now mark it as done. Perfect. So this is working. Now the only problem is that it's saving everything in memory, right? And now we want to change that and connect it to the database. But this is something I could already deploy. And deploy means I can now, since I just have 10 minutes left, I can just run this ARM template. And the ARM template is basically a way for you to tell Azure what you want to be created, so a description of the resource you want to be created. And as you can see here, I'm creating a static website. And the static website needs a source repository URL, and my repository URL will be exactly this repository here, which is the one that you should fork and then use as your deployment starting point, that contains the code that is actually running now locally, right? So if I move forward and deploy the ARM template using the Azure deploy shell script I provided, which is actually executing the deployment, you will end up using a static web app fully working, which is actually exactly this one. Now, in order to just show you everything, I want to move now to the V2 of this application so that you can see how easy it is to connect to the database. Because now the front end doesn't have to change anymore, because we know that the front end is sending and managing correctly the JSON. So no matter what happened in the backend, as long as we send back and basically manage the JSON in the same way, we can do whatever we want in the backend, and the front end doesn't have to change. And in fact, here, the only thing I did is I converted the logic to get to manage the get and the post and all the other method, so that instead of saving into in-memory list, I'm sending the data as JSON. So I'm getting the ID, wrapping it into a JSON object, and sending it to a storage procedure. The storage procedure here, which is this one, will actually execute some SQL code, and that SQL code will actually return a string, which is JSON. So I'm doing something on the database, but the output of the database is JSON itself. So it's super easy to parse it into JSON. Here I'm just returning it as JSON. I could have deserialized it into a to-do object if I also wanted to apply the schema here in the application. And how my database would look like, super easy. My table is incredibly easy. So I just have a to-do with the ID, to-do and completed, but my storage procedure is just taking JSON and returning JSON. So from a developer perspective, even the communication with the database is full JSON. And this means that as a developer, my life is much easier, because then I can simplify my code, because I don't have to deal with rows and columns and table and other stuff. I just have to have serialize to serialize and deserialize JSON, and that's it. So for example, here what I can do is create a database, and I will show you how even this can be automated in the process. But just for the sake of the time we have available, I already created a database. Now let me connect to it. And I'm just using the query editor here. Let me clean it up to make sure that my demo will work as expected. Perfect. And now I want let's stop this. what I want to do right now is deploy the database, right? So I have a database. I just want to deploy this SQL. There are several ways you can do that. Some other ways will be shown by Anna in his session tomorrow. Here I want to show a way I like a lot, which is writing a script and executing the script in a smart way. What smart means? Well, for now, I just only have one script. So I'm using a tool called dbapp that will automatically get all the script in this folder and apply them in the correct sequence on my behalf to the database. So all I have to do is go to the database deploy folder and do .NET run. This will connect to the database and execute the script. And as a result of that, I will have the database deployed. Nice. So if we can go here, we can go here right now and take a look at what's in the database right now. There is the to-do table I created, but also there is this $dbapp journal, which basically is something that is used by the dbapp library that I used to keep note of what script has been used already and what not. So if I re-execute this script, this deployment, it will not execute the script that has been executed before again, which means that I can deploy my database incrementally, which is great, right? Now, having deployed my database in my dev environment, what I can do here, everything is ready, my code is ready. What I can do is just, well, we can close this, let's move here, clear this up and run again my solution. Again, this will now be started. Emulator will spin up the server to serve the HTML front end and also the function to serve the back end. And everything will work super nice in the sense that now I can go here and here we go. With these values, now let's see, I have slides and demos here. I can go to the portal, actually it's here. So I can do select from dbo.todos and you will see that we have slide and demos. Now let's go to the same page and say, hi there. And let's say that I done the slides. So let's go to the database, run the query again, and you will see that everything has been saved in the database, right? Perfect. So this means that I coded my application correctly. My front end is correctly sending data to my backend and how my query would look like. So for example, this is exactly another example of just using the API without the front end here. So let's say I want to have all my to-do. I can just request this, and this is exactly the JSON that has been sent back to the front end in this case. If I want to create a new API, all I have to do is post to the endpoint, and this will actually create an API. So, and this is exactly what has been sent also to the database. And the database is actually sending back this. The backend is now basically working as a translator between the front end and the database to make sure that the JSON sent is correct, can be validated, and all this kind of additional stuff that for security we want to keep. Now, this is super beautiful, I would say. Now, let's make it a little bit more realistic because as you can see right now, anyone can actually come here and create a to-do, and I would be able to see the to-do created by anyone, but I want to be authenticated. I want to make sure that my to-do are only visible to myself. Now, the really beautiful thing about the local emulator, the static web app CLI, is that it also comes with an integrated authentication system that allows you to simulate OAuth2 so that you can actually simulate you connecting to a GitHub resource authentication provider or Twitter, so you can really have a fully working experience even locally. How we can do that? It's extremely easy, I can tell you, and we just have to switch to the v3, where there is also the authentication code inside the authentication mechanism inside the code. And you can see here that I am just querying this .outMe, which is something provided by static web app that would allow the code to understand if I'm logged in or not. if I am not logged in because this doesn't return anything, I just have to log in, for example, using GitHub. This works like magic. Let me show you. So let's go here. Let's start again my simulator with now this additional code, and you will be able to see that everything works perfectly as expected. So just, okay, perfect. Here we go. Let's go to this and refresh. And now you can see that I can log in here. And so let me try to log in. And here I can simulate the fact that I'm logging in with GitHub, and then I can log in, and then I'm logged in. And how do I know who is the user who connected to my application right now? Well, again, Azure Web Apps make everything super easy. In my code, all I have to do is parse a special header that has been set up by Static Web Apps for me that contains the information that has been received by GitHub or Twitter. So super easy. I decode basically this header that contains token information, and then I can have, for example, here a user ID somewhere. Here we go. For example, here I can extract information about the context which contains the user ID. Perfect. Now, this would work locally, but now let's pretend that I already done everything I need to do. I tested it locally. I want to deploy it. So to deploy, as said, I just have to run this ARM template. So let's do that. Let's stop this here and just run azure deploy.sh. This will actually create a resource group and will actually create a resource group that already exists. So it will be super fast. It will, let's see if I can make some space here, apparently not. So it will also create a new database. Well, actually, that's not going to do it because that's something we have to do. But we know that we need to have a to-do database here created. What it will be doing is creating a to-do app. Actually, I already prepared the to-do app in case we don't have enough time to do everything. So the only thing I need to do here is to change the name of the to-do app. Let's call it live. Nice. And let's deploy this again. And perfect. Here you have to specify other information. So the environment is something you have to create, but the shell script I prepared will help you. Basically, you have to specify where you want to deploy, the connection string to the database, and some information so that you will see the static web app client or deployment will actually create a workflow in GitHub for you. And actually, this is probably already done. This is usually quite fast. And what will be happening is that if I go to my GitHub repository, soon here I will see a workflow with the name of the application. So my application has been created and internally as a random name called Delightful Island. So if I go here to the workflow, I see Delightful Island. Perfect. This is actually what gets kicked in every time we commit something, and it goes and deploy the application, build the application, deploy the application on Azure for us. Now, the only limitation of this workflow here is that, of course, it doesn't know that I'm using a database, and I want to also include the database creation in the process. So to show you how you can do that, I also prepared a sample you can use. And literally, you just have to copy and paste from the action to the deploy and build. So let me do that. Here we go. You can go here. So I said from the action to deploy and build, so it will be exactly here. Nice. Let me correct the indent is done. Start commit, commit changes. Perfect. From now on, every time we commit, also the database will be deployed. And as you saw using dbapp, all the incremental script will also be deployed every time I add a new script to my database, so I can also evolve my database. If you go to action, let's stop this, cancel run, so we can just focus on the second one that contains also database deployment. this, in a couple of minutes, will actually deploy the solution, deploy database, and we will be able to actually have a fully working end-to-end solution that implements even security on Azure static web app with Azure Function backing it up for what concerns the API and Azure SQL for what concerns data management. This usually takes a couple of seconds, and this is also the end of my demo. So in the meantime, this deploys. If there are any questions, I am more than happy to answer some of those. So let me bring back my...
Hi, Davide. I think you're probably not watching the Learn TV chat, but it's been going crazy. There have been so many questions that have been answered. I hope you get a chance to go back and look at them.
Definitely.
I'll bring up one which I don't. Someone had just asked: is this a specific pattern for static web apps? And I think they're talking about your whole kind of end-to-end workflow. Quick.
So the pattern would work with any technology you want to use. A static web app, make it super easy, because otherwise you have to do everything on your own, right? So you have to figure out, how to, for example, configure the front end to make sure it can work with the back end. And usually CORS, which is something that usually tries to make sure that you don't get hacked, is something you have to configure. Is not always super easy. These basically remove all the friction and give you just an amazing experience.
Yeah, that was a question from Raj Krishnan, and thank you so much for that. I also wanted to say I love the CLIs. I mean, this is such an amazing session. You made it so seamless. But a quick question for you. I think we also have VS Code extensions for those of folks who prefer that.
Yes,
There's a ton of stuff with SWA and
there is a code extension for static web app. I haven't used it just because I'm more a code guy. So I like typing. But yeah, definitely there is also a code extension that will make everything even easier. Yes, absolutely.
So I'm going to put a challenge to people out there. David was using Vue, so you should fork this and do this with other frameworks and write up your articles on how you did this with VS Code. That would be awesome.
Yes.
Thank you so much. This was so amazing. I'm going to actually go back and watch this and write it up because this is exactly what we need.
Thank you.
Thank you so much.